Good day. Today we will discuss about certain topics in measurements and instrumentation. One of the core subjects in electrical and electronics engineering. I am Dr. Illampoornan, professor in electrical and electronics engineering. Our institute is Bharat Institute of Science and Technology. We shall discuss the topic of sensors. Sensor is a device which will produce an output signal from the sensed physical phenomena. It receives the signal and also responds to that particular signal, which can be stored as well as displayed later. But we have to use some storage device. The signal may be of any type, which is mostly physical parameters like heat, light, motion, or sometimes even chemical reaction. Once the sensor detects the signal, it will convert it into a continuous time varying signal, that is analog signal, or it may be a digital representation. Always it is better to go for a digital representation because most of the storage devices can be employed for storing digital information. Based on the explanation, we can conclude that sensors are used to detect many physical phenomena under various different conditions. Typical sensors convert a signal into electrical signal because it's always better that we obtain final electrical signal, either voltage or current, which can be stored in a digital format in any of the devices. Some of the common stimulus which we will employ for detection are given here. For example, the biological and chemical stimulus is obtained and it can quantify the fluid concentration or sometimes even concentration of certain chemicals in gas. The electric stimulus, it may be of any type such as charge, voltage, current, even electric field, whose amplitude, phase and polarization ought to be concluded. The conductivity is also another parameter in electrical phenomena to be measured. Permittivity is another kind of measurement which gives an idea of the capacitive aspect in a dielectric or certain phenomena like moisture in grains or insulation, etc. The magnetic stimulus is quantified by magnetic field. It may be various amplitude, different phase and polarization. Of course, flux and permeability forms the part of a magnetic stimulus. Optical stimulus can be quantified using the refractive index, the reflectivity, and also absorption, which happens in various surfaces. Thermal stimulus is quantified through temperature, thermal flux, specific heat, and thermal conductivity. Widely used mechanical stimulus can be quantified as the velocity, acceleration, force, strain, stress, pressure, torque, and then position. A good sensor has the following characteristics. It is sensitive to the measured property, whereas it is highly insensitive to the background. And of course, it should not influence the measured property. But in actual or practical case, the sensors has the following errors, such as sensitivity error, hysteresis error, offset error, nonlinearity, quantization error, aliasing error, noise, and drift. Main classification of sensors goes as active and passive sensors. The active sensors are having the power source in themselves. That means they do not require external excitation or external power supply. It is all called as self-generating sensors. Any sensors which is able to generate its power by itself and it can give output or classified under the heading of active sensors. The examples are photovoltaic cells, thermocouples, piezoelectric device. The other classification is passive sensors. The passive sensors requires an external supply, especially in the form of bias voltage, or we need certain amount of power which has to be given for its operation. The sensors are able to retrieve the measurements by an external support but without distracted by the environment. For example, the active sensors can do it by itself, like photovoltaic cell, they take the power from the exposed light, whereas in the case of passive sensors like strain gauge, you give the voltage but there will be a change in the resistance value which will result in current flow or change in the drop of the value. Hence, the passive sensors are actually requiring an external supply without which it will not be able to operate. Next, we shall see some of the examples of these sensors. The temperature sensor is one of the widely used sensors. They are used in the buildings where there is a possibility of high temperature or sometimes even fire. or they may be used in industry where there is necessity for maintaining the temperatures, and also there is the necessity of observing the temperatures. Similarly, they can be used in engines, appliances, or even computers, so that certain parts are not overheated and maintained at the standard temperature. So there will be a feedback loop which will be connected to the sensor, which will operate so that the temperature is maintained at an adequate level. Hence, the widely used temperature sensor has to be studied, and one of the example here given is RTD, a resistance temperature device. It has a specific metal or sometimes even semiconductors are used. Depending upon the coefficients, it is calibrated and the input temperature is converted into corresponding electrical signal which can be measured or stored. Thermocouple is another widely used instrument for measuring the temperature. Next, light sensors are required where the cameras are employed in order to maintain greater illumination or adequate illumination. We need a feedback loop which will take the input from the light sensors, which is shown in the diagram. It does not only take the visible light as an input, sometimes there are infrared information which are required, that is also taken from these type of sensors with certain modification in their material nature. They are well suitable for maintaining the ambient lighting. These sensors are having mostly semiconductor device, which is a photoconductor, so that there is variation in either resistance or there is a variation in conduction. Anyway, there is variation either in the flow of electron or variation in the gross nature of current. Photoresistor will vary its resistance based upon the ambient or input light. Similarly, photodiode or transistor varies in conductance based upon the input. Next, the magnetic sensors are used in power steering of various vehicles. They are also used for security purposes to detect any metallic objects, that is for screening the metallic objects. Sometimes, since all the current results in the magnetic flux around it by Ampere's law, they can also be used for current measurement, that is especially contactless current measurements on high current transmission lines. Another important sensors which are widely used both in laboratory and industry is known as proximity sensors. They are provided and used to detect the presence of object, how much the objects are nearby or sensed by these kind of proximity sensors, or sometimes it may be used for measuring the distance. They do not have any mechanical parts, hence they have very high life or aging is very low, and they are highly reliable too. The automotive engineering widely uses such type of proximity sensors, especially in the process engineering plants and production systems. They are also employed in the windows and in a vehicle. They are employed to alarm when you are very closer to another vehicle, which may cause a fatal injury or damage to the vehicle. These proximity sensors are also used for the measurement of vibration. So, if suppose a equipment causes a vibration which is equal to natural frequency, it may damage by resonance. To avoid it, these proximity sensors are used to monitor the vibration. Next, the sensors which are widely used in the plants where the biological degradation or chemical degradation is happening. They are known as biosensors, and they are of electrochemical in nature. Many biosensors are used in various industries like quality testing of food, medical, that is pharmaceutical applications, or even the patient monitoring system. If it is employed for an industrial plant where water hardness has to be monitored, or the mix of various chemical substances can be done monitoring with biosensors. Of course, it has the defense prospects too. So it will be used for detecting a biological weapon which surrounds it. It is another type of a sensor like sound sensors may also be classified, but they are belonging to a different category. And image sensors are also there. Biosensors, coming under the classification of the image sensor, can be used for normal attendance, that is biometrics, or traffic and security surveillance, can also be made fruitful or effective by using the sensors, that is biosensors. Many a time microphones are also employing these biosensor. Of course, there is an advanced sensor technology. To summarize, the sensor types are classified as the light sensor, which are very sensitive to the light. For example, the IR sensor, infrared sensor, which can be used as a transmitter as well as it can be used as a receiver. The infrared LED can also be used as a sensor. Photodiode is one of the important IR receiver because based upon the illumination it can vary its conductivity and hence it can produce a higher output or amplified output based upon the illumination. Next, there is another passive sensor kind of a thing which is called as a light dependent resistor. So the resistance value varies when the illumination varies. Regarding the temperature sensor, the thermistor is one of the important temperature sensor. Thermistor, the name itself explains the fact that it is a combination of a resistance which is varying based upon the thermal effect, that is temperature. Then thermocouple also comes under the classification of temperature sensor. Thermocouple is widely used and it has a two junction with one junction at a different temperature or even sometimes negative temperature. Another junction is at a temperature to be measured. The difference in temperature contributes to the voltage which can be calibrated for the temperature. Next, the pressure, force, weight or the physical quantities which can be measured. For example, the strain gauge sensor will measure the amount of the pressure applied over it. Similarly, the load cells they can be used as a weight sensor. Other classification are biosensor, chemical sensors, etc. Next, we will discuss about the transducer. Transducer is a device that converts energy from one form to another. Usually, in electrical application, we can make use of a transducer which will convert any other form of energy into electrical signal. Requirement of the good transducers are listed as first one, it should be smaller in size and also in weight so that it can be fit or it may be manipulated very easily. Next, it should have very high sensitivity. As already we have discussed in the first part of the video, we have sensitivity which is defined as the variation in output to the variation in the input. So the amount of sensitivity implies the transducer responds very quickly to the input variation. The third one is it should withstand the environmental conditions. That is, it should have good adaptability to the temperature condition which is surrounding it or the pressure condition. Sometimes even chemically abrasive materials will be there. So our transducer should withstand or protected from all these kind of influences. The last one is about the economic nature of transducer. Of course, it should be of lesser cost. Now we will see the broad classification of transducer. The transducers which will convert non-electrical quantity into electrical quantity are discussed here. Of course, you can use transducer for doing the reverse process also, but we are focusing mainly upon the conversion of a non-electrical quantity into electrical quantity as we are electrical engineers. The transducers, especially the passive transducers, are classified into a variable resistance transducer, variable reactance transducer. Another important division of passive transducer is optoelectronic transducers. The variable resistance transducers are further classified into the photoconductors like photodiodes, phototransistors, which vary their conduction depending upon the illumination. Then strain gauge, this is the variation in the resistance due to the dimensional change. Thermistor, depending upon the input temperature, the resistance varies. Even though the underlying concept of variation in resistance is there, they receive various input, various forms of input for it to vary. Next, the important discussion is about the variable reactance. The variable reactance can be further classified into inductive reactance and the capacitive reactance. Of course, the capacitive reactance, we know the well-known formula epsilon A by D. Epsilon is permittivity. So if you vary the epsilon, then the capacitance will vary. Similarly, we can vary the area, that is A, and also the separation between the plates. So all these three types of variation will produce the capacitive reactance variation. The variable reactance transducers, that is inductive in nature, are given by the formula. We can assume the inductance is equal to N square by S, where N is the number of turns, but S is the reluctance. If you further go into what is reluctance, S is equal to L by mu A, where L is the length of the magnetic path, then mu is permeability and A is the area. So the inductance can be varied by varying any one of these parameters like the length of the magnetic path or the area, which will contribute for variability of reluctance. Similarly, the permeability may also vary and also produce the effect of variation in inductance. The widely used the displacement transducer, linear variable displacement transducer, employs the inductive variation, especially the mutual inductive inductance variation. Eddy current is the leakage which is produced over the core material that can also be used as an indicator for inductive variation. The optoelectronic classification of passive transducers can be classified as photoemissive type and photojunction type. For the photojunction type, the electrons will vary based upon the junction illumination. Photoemissive type, it will emit light based upon the current flow through it. Let us discuss further about the resistive transducer. The resistive transducer is the transducer which will vary its output based upon the variation in the resistance. It is also known as resistive sensors. It measures temperature, pressure, displacement, force, vibration, etc. The resistive sensors works on the principle that the conductor length is directly proportional to the resistance, that is the L is directly proportional to the resistance, the area is inversely proportional to the resistance, area is inversely proportional to the resistance, the resistivity is directly proportional to the resistance. Resistive transducers widely used are the strain gauge. It is made up of the resistance of a metallic semiconductor. Due to the elongation or compression, it can be used for the measurement of torque, displacement or force. Similarly, the resistance thermometer, the change in the resistance of metallic wire due to the change in the temperature, can be used for the measurement of temperature. The resistance hygrometer, the humidity can be measured based on the variation in the resistance. Hot wire meter, depending upon the convection, the cooling of the flow of gas is not corresponding to the resistance change can be obtained, and it can be used for the measurement of gas flow or pressure. The photoconductive cell, the change in the light can be used as an input. The corresponding change in the resistance will be taken as output, which can be measured based upon the change in the flow of current. Thermistor is using a semiconductor which is usually having negative temperature coefficient and also used for measuring the temperature, and potentiometer type is using a slider wire where the variation is measured based upon the input pressure or displacement in terms of resistance.